Okay, last question. A pane of glass is sometimes beveled at the edges. That means that the edge has been slightly shaped. A diagram below shows what this means. The next diagram shows an enlarged view of a pane of glass at its beveled edge. Two rays of white light are shown, striking the glass. Complete the diagram to show how the beveled edge of the glass can produce a coloured beam of light, while the main pane of glass produces no colours. Label the rays with appropriate colours. Now, I think I'll just do the bottom one first of all. So it says the main pane of glass, so it's this bit all down here, okay, just shows no colour, so it just travels straight through. But really what this top one here is saying, use that top bit as a prism. So what I'm going to do is I'm just going to turn it round slightly. And if you just imagine that as a prism, a ray of light entering a prism, and so there's your ray of light bent towards the normal, and so we'll get something like this, and bent away from the normal on the way out again. Remember I said before about that shape, just like you were drawing the roof of a house when you were a child. And then the second ray of light, then you could bend like that, and it's bent more when it comes out. Something like this. Okay, and then we're going to label those rays of light. So this one here is a red one, and this is a violet one. It says label the rays with their appropriate colours. So red, orange, yellow, green, blue, indigo and violet. But they're really only looking for the two colours, red at the top and violet at the bottom. An arrow in all rays that you have gone through as usual. Okay, so you have got marks for red at the top, violet at the bottom. Your emergent ray, your two emergent rays here bent away from the normal will get you 1 mark. Your two rays going into the glass here bent towards the normal on their way in will get you 1 mark. So that's 4 marks for this and 1 mark for that one. Now if you have only one ray at the top, you could get a maximum of 4 marks. So even though you've missed out on your violet ray, if you have shown bent towards the normal, bent away from the normal, and red at the top, red at the top, you could get 4 marks there. So that's not bad if you can try and see your way around that. What is meant by the diffraction of a wave? So diffraction is that spreading out idea when it passes through a gap. So they're quite happy with you answering this, the spreading out of a wave as it passes through a gap. The diagram below shows wavefronts moving from left to right. Complete the diagram by drawing an object in the path of the wavefronts, which would make the wave diffract, and show the shape of the wavefronts after they've passed through the object. So we're going to draw a barrier in here, and for me to be able to see this, I think I'll just draw this by eye rather than using a ruler. And I want to make the size of my gap about that size there, which is approximately 17 millimeters. So I'm going to make the size of my gap about the same. And I'm doing that, the reason I'm doing that is so that we can get the nice round diffraction pattern that you've seen before. So that's the barrier or the gap. And the wavelength we said there was about 17 millimeters. And so we're going to have our waves roughly about 17 millimeters apart and try and make them nice and even. So a nice circle here, something like that, and then another one. Something like that. And they should be able to see that you understand that the wavelength is more or less the same. Alright, so you'll get 1 mark for the size of your gap and 1 mark for the shape of your waves as they pass through. Part C, the diagram shows a path of a ray of red light passing through a glass prism. Name the process happening to the ray at point X. So you can see point X has been bent, and so that's refraction. It says then there's no light emerging from the prism at Y. Name the process happening to the light at point Y. If we have a look again there at point Y, it's been totally internally reflected. Now you will get away with saying T-I-R and you get your mark. Be very careful if you are writing it out totally internally. It's reflected, not refracted. You will get it marked wrong if you write refracted. How does the speed of light change, if at all, as it passes point Y and as it passes the point Z? So we'll just look at this diagram because it's the same. As it passes Y there, it's been totally internally reflected. It hasn't changed medium or anything, so there's no change, or it's the same. But when it passes Z here, it's going out from glass into a much less dense medium, and therefore it speeds up and bends away from the normal. On the diagram, using a ruler, continue the path of a second ray of light through and out of the glass prism. Now you can see that this ray here is parallel, and it's the ray of light inside the glass is going to do exactly the same thing as the top one. And everything's going to be parallel because it'll be bent by the same amount here, it'll be reflected by the same amount here, and refracted by the same amount going out again. So what you have to try and do is try and get your rays more or less parallel. So I'll move the ruler down there. That looks fairly good to me there. Okay, and then this ray here is going to be parallel to the YZ one. And if I move this down, I'm hoping that I'll get something fairly similar. Okay, so something like that. And it's going to hit this top corner, and then it's going to pass out of the glass again parallel to this one here. Like that. And we're going to put arrows on them. So if it looks fairly, all the rays look fairly parallel, you're going to get your 2 marks in the glass.